Thanks, everyone. Oh, it's such a big pleasure to join the Semantic Web Technicon of the ESIP. Today, I will present a very small work we have been doing very recently. I have about 29 slides, so I may need between 25 to 30 minutes for the whole presentation. The topic I will present is something you may already be very familiar with, is the knowledge graph. That's how we call it nowadays, but you can also call it ontologies and vocabularies for the geological time, but we just call it a deep time knowledge graph nowadays. And today I'm going to present a recent work we're doing on the version control in the deep time knowledge graph. Okay, let's go on. I will present a few parts. First is just a very short introduction to our understanding of the knowledge graph, especially for those who are not familiar with ontologies and vocabularies. And then the second part is a highlight of our work, is how we design the version control structure and how we incorporate the existing ontology and vocabularies, especially those developed by Dr. Sam Cox and his colleagues. And then the third part, I'm going to show you a few examples when we set up the graph and then build a triple store. How can we query the version information in this knowledge graph? So here is a brief understanding from our point of view is how we understand a knowledge graph, because deep time knowledge graph is also a type of knowledge graph. And we think a knowledge graph, normally we understand it as a mixture of T box and A box. T box is a list of classes and properties. It's just like a classic ontology in people's understanding. And the A box is a list of instances of those classes and properties. So I think a knowledge graph nowadays, normally we can understand it as a mixture of those two. We can see both classes and instances in a knowledge graph. And then for the deep time knowledge graph, there are several existing works, but I think the most representative one is the ontologies and vocabularies developed by Dr. Sam Cox and his colleagues. And there are two key classes in the T box, the deep time ontologies. One is, we call it instant, it's a point in the time, and another is interval. It means a period of time. And they have built really good ontologies and vocabularies and also services. If you go to the Geoscience ML website, in the webpage resource.geoscienceml.org, you can find a link to a folder in which you can find a list of those ontologies and vocabularies built by Dr. Cox. And also very recently, many of you may have already saw the progress, the W3C time ontology. There was a version released in, I think, in 2017 or 2016, but just, I think, a few weeks ago, I think this work was led by Dr. Cox and his colleagues, since they made some new updates to the W3C time ontology. And now there is a candidate recommendation from W3C. But the time ontology has also been incorporated into the geological time ontologies and vocabularies, when other was the deep time knowledge graph. So this is a brief introduction to the progress so far. Here I will give a little bit more details about those two classes, the two top classes in time and also in geological time, interval and instant. So for interval, we can understand it in geological time. We can also understand it as a unit. It's a period of time. And the instant, we can understand it in geological time as a boundary, or in other words, is a particular point in time. If you look at the screenshot in the bottom left part of the slide, is just part of the geological time scale. If we only look at the Jurassic, and you can see the start and the end of Jurassic, each of them is an instant, or in other words, a boundary or a point in the time. And then Jurassic itself, you can think it as a period of time. It has a start, it has an end, and it has a duration of time. So you can see geological time is also time. So we can also apply those two key concepts or two top classes to the geological time structure. And another interesting feature of geological time, I just borrow some ideas from Dr. Cox. Because geological time, you can understand it as an ordinal hierarchical structure. So the ordinal part, time is an ordinal sequence, right? From past to present, from old to new. So time is an ordinal structure. But just for geological time, in geoscience, people use different levels of units, as you can see here on the top. So you can see era, period, epoch, age, different levels of units for those concepts. People writing in human language. So geological time scale is also a hierarchical structure due to the usage of those units. It's a kind of hierarchical structure of units. So we call geological time or deep time as an ordinal hierarchical structure. And here you can see a list of those core ontologies and schemas used in the existing geological time knowledge graphs. Those are all developed by Dr. Cox and also Dr. Steve Richard and their colleagues. There are several very interesting ontologies. If you are new to this geological time ontology topic, you can take a look at this one, THEORS. This one was derived from ISO standard, and also the GTS, and also recently the time ontology. This is a W3C recommendation. But here we'll begin to introduce the challenge. And so Dr. Cox and his colleagues, after first building the ontologies or the group of ontologies, they begin to encode vocabularies for this international coronal stratigraphic chart. But a very interesting pattern in the International Coronal Stratigraphic Chart is organized by the International Commission for Stratigraphy. And the interesting pattern is that every year, this commission, International Commission for Stratigraphy, they release sometimes one new version of this chart, and sometimes they even release 2 or 3 new versions in a single year. So you can see it's evolving. This chart is evolving. And so Dr. Cox and his colleagues, actually, I think sometime later we may invite Dr. Sam Cox to give a presentation about this work. And they are trying to release a new vocabulary corresponding to each new chart. As you can see here, you can see starting from 2004 until now in 2020. In 2020, actually, I already see a new version of this chart. And they have built a new vocabulary for each version of this chart. And they also use this SISVOC, SISVOC, to set up a kind of vocabulary service for those vocabularies. And they use a really interesting structure in the vocabulary service. The UI of a concept, when you resolve the UI of a concept, it will automatically redirect to the latest version of the vocabulary. So as an end user, the UI of a concept is always the same. But when you resolve the UI in a web browser, it will show you the information in the latest version of the vocabulary. So that's an interesting feature of the SISVOC vocabulary service. Okay. But still, I found a really interesting limitation in the existing vocabularies developed by Dr. Cox. It's about representing, and that's also our objective, is to represent the version information in a single knowledge graph. As I mentioned, in the existing work of Dr. Cox, they are trying to build a separate vocabulary for each version of the ISA chart. Okay, this is kind of very tedious work. You build a separate vocabulary for each chart, and the International Commission for Stratigraphy, they release one or a few new charts almost every year. So this can be a really tedious work to create a new vocabulary every year. And also, because I think in the earlier years or in the earlier days, Dr. Cox used some different ontologies in the vocabulary. And in recent years, he began to incorporate the time ontology in the deep time knowledge graph. So there are also some ontology versioning in this work. And this may cause some challenges if we want to query the existing vocabularies and if we want to track the version history of concepts and relationships, because there are different ontologies used in those different versions of vocabularies. It can be a challenge to do the query. So our objective is trying to represent the version information in a single knowledge graph, but our aim is not to reinvent the wheel. We are going to reuse all those existing ontologies, especially the latest ontologies and the vocabularies. We will not add any new classes or new properties, but we just add a very interesting structure to represent the version information. So now let me show you some more background information about the versioning patterns in the International Coronal Stratigraphic chart. We can see the versioning happens at several places. In one place, we may call it a concept versioning. So if you look at the place at Holocene, this screenshot on the right is just a part of the chart in the version 2017 February, and then the one on the left is a newer version, is 2018 July. So you can see there are 3 new concepts added in Holocene, and you can see each of them has a new name, and also for 2 of them, you can see a new golden spike were added into the chart. So we can see this as new concepts added into the chart, and I will just call it the concept versioning. And we can also see attribute versioning. So if you look at the chart on the right, this is earlier version. This is a 2018 July. The one on the left is a newer version, but it's just 1 month later. It's a 2018 August version. But then if you look at the base boundary of this concept, submarine. So if you look at the early version, you can see the base boundary, the number in the base boundary is 295 something, right? And then in this newer version, the base boundary was updated to 293 something. So it's just a number in the base boundary changed. So this is attribute versioning. And we can also see relationship versioning. So what is this relationship versioning? If you look at the concept quaternary, so if you look first on the top left and then go to right, and then you look at bottom left, go to right, you can see since the version 2004 until the version 2018, we can see a lot of change happened to quaternary, especially the location of quaternary, and also the relationship between quaternary and other time concepts in this geological time chart. So you can see in 2004, I know something happened in the geoscience community. Quaternary was removed from the geological time chart. And then in 2005, quaternary was added back, but it's as a kind of temporary decision to add quaternary back. But then in 2008, you can see, okay, quaternary is kind of has a formal location in the geological time chart, but still for some boundaries, like here, how can we decide when this concept, Glacier, the relationship between Glacian and Pleistocene and Paleocene. There's some interesting relationships here. And then come to 2009, you can see this boundary changed again. Seems the relationship was made formal. And then you can see the change of concept names at some places. So you can see Quaternary is a really interesting concept in the geological time chart. But just from my perspective, when I was doing the conceptual modeling, I can see, oh, the relationship between Quaternary and other concepts change a lot when I look through those different versions of this geological time chart. So as you see, we can model and track the version history of concepts, of attributes, and also the relationships. But how should we do this? Here is how we do the design. I already mentioned I don't want to redesign the well, so what I'm trying to do is reuse the existing ontologies and vocabularies, and do not add any new classes or properties. And then our aim is to show a complete version history. And then we can also map back to the current geological time vocabularies. Our core idea is to use the vocabulary scheme IDs, but we just need a very interesting, a good structure to specify which concept, which attribute, and which relationships are in which vocabulary scheme. We need a structure to represent that. Okay. Let me show you some source code. If you look at those 4 small windows, here are a representation. This is just a title code representing the base boundary age of Jurassic in 4 different vocabulary schemes in the vocabulary scheme 2004, 2010, 2012, and 2017. So you can see we look through those 4 versions. The first thing I can see is there are different ontologies used, especially if you look at the latest version, the 2017 version, you can see the time ontology is used. So when you look at this representation of the numerical position, you can see a property from time ontology was used. But then in the previous versions, time ontology was not used yet. Okay. But then you can see the ontology usage changes. You can also see the base boundary value change. So in 2004, you can see the base boundary 199.6, and then in 2010 it's still the same value, right? And also the uncertainty is the same. And then when you look at the version 2012, you can see the base boundary value changed to 201.3, and the uncertainty is 0.2, and this remains the same in the 2017 version. So when I visualize this title code in a diagram, I can see it as the 4 diagrams you see on the left. So J here means Jurassic, BJ base Jurassic, and then base Jurassic position or base Jurassic time, BJT or BJP. This is how the property name was used in the original ontology and vocabulary. So I can represent those 4 pieces of code in those 4 diagrams. And then if I want to put all those 4 diagrams in a single one, I can use a structure as you see on the right. So, but I just make a really interesting usage of the vocabulary schemes. So the core concepts remain the same. So Jurassic, base Jurassic time, and base Jurassic uncertainty. Those 4 concepts remain the same. but I just use the vocabulary scheme ID. So here we have 4 vocabulary schemes, 2004, 2010, 2012, 2017. But then just for the value and also the uncertainty in the base boundary, we need to specify which value is in which scheme. So for example, here, the 199.6, this number of the base Jurassic time, it appears in the 2004 and the 2010 schemes, the same for this uncertainty value. And then for the base Jurassic time, the number 201.3, this number appears in those 2 schemes, 2012 and 2017. The same for the uncertainty. So you can say what I have done actually is a very simple idea, to add the scheme ID not only to the concept but also to the attributes here. In this way, we can track it. If you only look at if you only add the scheme ID to the concept level, it's very hard for you to track the change at the attribute level. If you don't have scheme ID for the attributes, you really have no way to track the changes in the values. So that's also what I just mentioned. Here is how we can add the scheme ID to the concept level. If you only look at the Jurassic, not as the attribute of Jurassic, if you only look at the Jurassic, we can say, okay, Jurassic is in all those scheme IDs. This structure actually was already realized in the original vocabularies developed by Dr. Cox. So if you look at those, if you look through all those vocabularies, separate vocabularies built by Dr. Cox, if you put all those vocabularies together, actually you can also see this structure. But just for the attributes in the original vocabularies built by Dr. Cox, we are not able to see the scheme IDs, and it's almost impossible to track the version change of the attributes. So here you can see, when we put all those version changes from 2004 version to the present, here's how we can represent the versions of those attributes in the title code. I just used DC description and then used a blank load. You see the square brackets, and then I put the numerical position. For example, here the 201.3, and then in scheme. So this number appears in which scheme? I just put the corresponding scheme IDs here together with it. And the same for another version of the number. I just put the corresponding scheme IDs together with it. The same for the uncertainty. Here is the source code, the title source code for the specification of the relationships between Jurassic and other concepts. For example, if you look at this SQS, broader, transitive, narrower, and also the time ontology properties, interval in, interval midst. Here the relationship actually is easier because I did not see too much relationship updates between Jurassic and other concepts. But let's see a complicated situation. We mentioned quaternary in a previous slide. So the relationship between quaternary and other concepts change a lot, right? Along with the different versions of the chart. So how can we represent this relationship versioning in the title code? Here's how we do it. You can see a lot of changes when you look through these charts. But when we come to the title code, the representation, I think we just use 3 blocks, the DC description, and then 3 blank loads with the square brackets, and then the relationship between quaternary and other concepts. You can see 3 patterns. And then the corresponding vocabulary scheme IDs. It's just the relationship between quaternary and other concepts. Here you did not see the scheme 2004. It's just because there is no quaternary in the 2004 version of the time chart. So here in the code, you cannot see the scheme ID 2004, just because quaternary is not in that scheme. And I mentioned one of our guidelines was to make it consistent with the existing ontology and the vocabularies. So you can see in our work, we just make a interesting usage of the scheme ID. We reuse all the existing ontologies and the property classes and the properties. We do not make any changes to the classes and the properties. And as a result, all the versions of the geological time chart, the international coronal stratigraph chart, they can be represented in a single vocabulary. And then the URI of each time concept and also the URI of each attribute to remain the same as in the existing vocabularies. And we did make some tiny change to the scheme ID. We just want to make it consistent. I mean, when we look through all those scheme IDs, so we just made a change to the scheme URI, but we can map it back to the scheme IDs, the vocabulary scheme IDs in Dr. Cox vocabularies. And here you can see how we can do the mapping. But still, I can see a little bit more work to do here is because I mentioned in some years, there are two versions of the vocabulary. But since in Dr. Cox's work, for those years, he built only one vocabulary. So I may need to take some time just to look into the details to see which version he built the vocabulary for. And then I can make a correct mapping at here. So the result is title file. In a single vocabulary, we have all the versions of the geological time charts. We also build a Sparkle endpoint with the graph name here. And we also build a front-end website. Here we can release some latest progress and also some front-end applications of this vocabulary. Here I want to show you some example queries towards this Sparkle endpoint. For example, if we want to find the age and uncertainty at the base of Jurassic in a given version of the chart, for example, the version ISC 2012 August. Here is our first use case. We just write the query like this. For example, we use the label Jurassic, and then we just use the ontology pattern for describing the versioning. So we just use DC description. It has a beginning, that's the base boundary, and it's in scheme, and we give the corresponding scheme ID. Okay. And same thing, we use the patterns in the ontology patterns in the knowledge graph to track down to the numerical value of the base time and also the uncertainty in the boundary with the corresponding scheme ID. So in this way, we can just find the number of the base Jurassic in the version 2012 August. And here's the result. And in the knowledge graph, we do have some interesting situations. For example, for a boundary, if the boundary is not defined in numbers, Dr. Sam Cox, he used a different property for that situation. So if it is a number, you can see a property, numerical position, right? But sometimes if the boundary is not defined in the vocabulary, it can be just a label, for example, not defined. So in the vocabulary, there's a different property called a nominal position. So we need to incorporate that situation. We need to have, and here we just use a union clause to tackle that situation. And also, sometimes for some boundaries, they do not have a value for the uncertainty. It's just a blank value for the uncertainty. We also need to tackle the situation, and here we use optional clause in the Sparkle code to address that situation. So here, if we search, for example, Arcane, you can see the base time value is a nominal position. It's not defined. So this union clause will address that. And if we change the concept to be queried to holothane, we can get a result like here. It's just the base boundary uncertainty is not defined in the vocabulary. So you can see a blank value here. And this was addressed by using this optional clause in the Sparkle code. And our third use case is also interesting. We say, okay, since our aim is to trace the version history. So here in this use case, we say, oh, for a given concept, can you give me a list of all those values among all those different vocabulary schemes? Usually here, when we write the Sparkle, we saw we can just make a very small change to the code we used in the previous two use cases. We just use a variable instead of a certain schema ID at here. We just use a variable to represent the schema ID. And then at the end, we use an order by descent of the schema ID. So from the latest version to the oldest version. The result you can see is on the right. So by using this Sparkle query, we can get a whole list of the base boundary time and the base boundary time uncertainty of traffic along all those versions. As long as they are recorded in the vocabulary, we can find it out. And here is a short summary. I think the ontologies and vocabularies developed by Dr. Cox and also Dr. Steve Richard and their colleagues represent the latest work of geological time ontologies, vocabularies, or in other words, the deep time knowledge graph. But it's still a tedious job if we build a separate vocabulary for each version of the ISA chart. And also, because Dr. Cox was also trying to use the latest ontologies, especially the time ontology. So we can see the change of ontology patterns along with his earlier work and the latest work. So this makes the query across all those vocabularies a little bit kind of challenging. And our work addresses this limitation. We can put all those version changes to concepts, to attributes, and also to relationships in a single knowledge graph. But still is an empirical approach. And even now we're still updating it. For example, I can see the International Commission for Stratigraphy, they are releasing new versions of the chart continuously. And so now we're also trying to incorporate the new version of the chart released in 2019 and also in 2020 into this knowledge graph. The work was supported by the National Science Foundation, and we're also communicating the work with several other communities. If you have interest in this work and want to see more, you can come to our website where you can find links to the GitHub repo and also to a few demos and applications. And you can also find our contact information on the website. Here's my last slide. especially for those who are interested in the deep time knowledge graph. Here's a list of those published papers and also a link to some resources. Yeah. That's all my presentation. Thank you very much for your time. I will be very happy to answer your questions and to hear your comments.
Excellent, Marshall. Thank you very much indeed. Very, very interesting work, and obviously growing on a lot of very important work that's taken place by a number of individuals over quite some time. Does anybody have some questions for Marshall? I'm unsure whether to keep the recording going at this point in time or else to essentially kill the recording and we can just take it from here on. What do you think?
Yeah, maybe just keep recording for the Q&A and then
Okay.
Yep.
Sounds good.
So Marshall, maybe you can do this after Q&A so you're not distracted, but could you please share the links to the endpoint and the GitHub repositories that you showed in the slides on either on chat or if you're on the Google Docs, please? So we can record that.
Yes, let me see. I think it's somewhere here.
So Marshall, this work has been submitted to Computers and Geosciences, is that right?
Oh yes, I submitted this, I think, about 2 months ago.
Mm-hmm.
Yeah.
Yeah. So I think we'll probably expect to see that published there within the next while. Okay, great. For those that are interested, by the way, we had started a conversation round about unifying all of this work which is going on with representing temporal characteristics in schema.org for that particular ESIP cluster, and then how time is currently, well, manifested within Suite. And that's a pretty large project that needs to be scoped properly in order to achieve it within an ESIP Labs project. But if you're interested in that, there is a time_semantics Slack channel on the ESIP workspace if you're interested in that. I think this is really interesting work, Marshall. Very, very interesting work. I just wonder, the endpoint there, the Sparkle endpoint, is do you intend in that being up, like it persistently, that being available for some time?
Yeah, I think it will be at least I think for a couple of years.
Yeah, great. Okay, so that will give people an opportunity to try out a few queries.
Lewis, yeah. Simon Cox here. Do you hear me?
Yes.
Yeah, okay. I've dropped a couple of links into the chat already. We recently moved the GitHub repository from, I think it was in a Geoscience Australia one, but it was buried in with a whole lot of other stuff. And we've broken it out, both the ontology and separately the data sets, into a repository now in an organization named for Commission for Geoscience Information and International Union for Geological Sciences. That's the address of that is in one of the links that I've already dropped into the chat. The other piece of news on this is that the International Commission of Stratigraphy have had a refresh of their leadership relatively recently, and the website is undergoing a revamp, and part of that is actually adopting these semantic versions of the stratigraphic chart. There's the first link that I posted to the chat, if you can see it, is a demonstration. It's not it's got some issues with it, but it's a graphical representation of the semantic version. So it's built from the semantics and gives you color coded using the standard colors graphical representation. That's expected to improve over forthcoming time relatively shortly.
Yeah. Oh, Sam, nice to hear from you. I think last week, when I was on their website, I saw they already put a link to the vocabulary service. I think the link you sent to me maybe 1 year ago is you mentioned it's kind of a student project. But it's a really nice visualization of the geological time chart, and also with links to your vocabulary service. I think on the International Commission for Stratigraphy on their website, they already put a link to.
Yes, that's the link that I just put in the chat. That is the link that I just put in the chat. So it's interesting to see Marshall's work on this. This obviously referred to a lot of my past work. This was always a kind of a background project. Never had any funding, which is why it's sort of a little bit all over the place at times, and was never actually pulled together to be fully consistent. We just, when a new version came out, recoded it. As Marshall pointed out, if we had a newer, better version or different version of the ontology to use, we used that and didn't go back and reprocess the previous ones, because there was actually no resources to work on this project. Mostly, to be honest, I did this work as an example of a rich vocabulary service. So it was just an example that I knew well because of my geoscience background. But there was a couple of motivations for doing it, technical, over on the technical side. But the kind of analysis Marshall's now doing, I think, is very interesting and very useful, and is an obvious sort of follow-on.
Right. Thanks, guys, for the questions. All right, we've got a lot on the agenda still. I think we should probably maybe end with the Q&A for now, unless there's another pressing question for Marshall.
This is Ruth. I have one hopefully quick question, and that is, so this is kind of a pattern for how to change the relationships and concept meetings and things like that as they drift over time. And I'm wondering, do you think this is a reasonable, pattern for doing that in general, not just for these concepts, but for other concepts as well? Because I do note that many of the scientific concepts that I'm familiar with do drift over time and space and community even.
Yeah, I think a short answer to your question is yes, because here, when I look at this geological time chart, I just treat it as a kind of concepts, not exactly the time concept or something. So I can see this structure can also be reused to any other concepts or objects, as long as if they have a versioning issue or version change along the time. But I may pick up a use case from other domain, and then I can see whether this structure is reusable.
Well, maybe we should talk.
Thank you, Ruth.
Yes, I agree. You've hit the nail on the head there, Ruth.
I have one very quick minor technical question for you, Marshall. I noticed that you were using blank nodes to describe, like say the Jurassic and how it changes over the versions. Just wondering if that was intentional, or if you'd consider maybe just minting an IRI for that so that those nodes were dereferenceable in the future.
Yeah, it's just an empirical approach, because when I see along all those versions, you can see there are a lot of versions in the geological time chart. So in my very original discussion with my students when we were designing this structure. We also talk about, oh, should we also add a UI or IRI to those blank nodes or blank blocks? If we do that, it can be a kind of tedious job. But if we have a mechanism to do that, that's also a way to do that. That's also a way. But finally, we just say, oh, let's just take a trial of the blank node, just see if it works. And after running a few rounds of tests to those use case and concept, we see, oh, it works. So we just apply it in this way. It's a very empirical approach. And also in our test, we see if we do add a IRI to those blocks, seems it will not add too much meaning or too much value when we do the versioning tracking. So finally, we just say, okay, let's just use the blank nodes instead of using a specific UI for each block in the version information.